All right, let's dive right into this explainer. When most of us think of pest control, we probably picture some guy in a hazmat suit just blindly spraying chemicals into every dark corner, right? Well, actually, the reality is a lot closer to a high-stakes forensic investigation. Today, we're exploring the wild and honestly fascinating world of practical pest taxonomy. We are going to see exactly why treating an infestation without first perfectly identifying your prime suspect is an absolute recipe for disaster. So, welcome to the world of the pest detective. Let's get into it.
So let me ask you a question. What actually happens if you profile the wrong suspect? I mean, picture this. You walk into your kitchen, you spot a tiny trail of ants marching across your counter, and you instinctively just grab whatever bug spray is under the sink and blast them. Problem solved, right? No, absolutely not. In the professional world of applied zoology, an identification error means you're using an entirely wrong treatment plan. And that wrong treatment doesn't just fail, it can actually backfire and make your pest problem exponentially worse, which costs serious money and, as you'll see, creates some pretty massive health risks.
Let me give you a prime example of this, the pharaoh ant. If you misidentify this specific heat-loving tropical ant as just a run-of-the-mill garden ant and hit it with a standard contact bug spray, well, you've just triggered a biological defense mechanism called budding. When these ants feel threatened by that spray, the main colony literally hits the panic button and fragments. They scatter deep into your walls and almost instantly set up dozens of brand new, completely separate colonies. So by attacking a suspect you didn't properly identify, you've just taken a minor, totally manageable kitchen problem and exploded it into a building-wide nightmare.
To avoid catastrophes like the whole pharaoh ant situation, these biological detectives rely on a very specific, absolutely crucial tool called a dichotomous key. Now, it sounds a little academic, but the genius of this tool is actually in its simplicity. A dichotomous key is basically a classification tool built entirely on a strict sequence of binary yes or no questions. It completely removes guesswork from the equation and forces a technician to rely on pure, observable physical evidence to track down exactly who they are dealing with.
Let's actually walk through a rapid-fire example of how this yes or no logic works out in the field. Okay, step 1. Does our little suspect have 6 legs? Yes. All right, boom, we know for a fact it's an insect. Step 2. Does it have wings? No. Okay, so now we've narrowed the field down to a crawling insect. Step 3. Is it brown or reddish with long antennae? Yes. And just like that, in 3 simple binary steps, we've definitively tracked our suspect down to a cockroach. We just mathematically eliminated hundreds of other potential bugs in a matter of seconds.
All right, let's bring in our first official lineup, crawling suspects, specifically cockroaches.
In this lineup, microscopic physical clues dictate your entire battle plan. The absolute key here is understanding the wild juxtaposition between these two very different suspects. Take the German cockroach. It's tiny, maybe 12 to 15 millimeters, has 2 distinct dark stripes on its back, and it absolutely loves heat and humidity. Think the cozy spot right behind your refrigerator. On the flip side is the oriental cockroach. This guy is much bigger, 20 to 27 millimeters, totally dark black, and thrives in cold, damp, miserable places like basements and freezing sewer lines. If you confuse these two, you're going to end up placing gel bait in a hot kitchen when you actually need it to be spraying residual chemicals down in a freezing sewer. You're literally fighting the wrong war.
And guys, you absolutely cannot afford to waste time with the wrong treatment because just look at this number, 300 descendants per year. That is the insane reproductive potential of just one single German cockroach under the right conditions. Their life cycle is blindingly fast, and they build up chemical resistances incredibly quickly. If a technician doesn't spot those 2 dark stripes immediately and deploy the exact right strategy, a few hidden bugs will turn into a crawling colony of thousands in just a few months.
Moving right along to lineup number 2, flying and biting suspects. Now, for the airborne vectors, tracking down highly specific breeding grounds is our ultimate clue. Mistaking one flying suspect for another here is a massive error. Let's compare the common mosquito with the tiger mosquito. The common mosquito, it's brown, mostly hunts at night, and likes to breed in large pools of stagnant water, like a flooded drain. But the tiger mosquito, this one is black with really striking white stripes, it aggressively hunts during the day, and it breeds in incredibly tiny volumes of water. I'm talking a teaspoon of water sitting in the tray under a potted plant. Treating for tiger mosquitoes takes a totally different, hyper-focused strategy to find those hidden daytime water sources.
And there's a wider rule for all these biting and flying threats. Every single suspect has a highly specific origin point that you have to find. Take houseflies. You have to physically find and remove decaying organic matter because insecticidal spray alone will not work if the breeding ground is still there.
Bedbugs, which are literally exploding globally right now, hide incredibly deep in mattress seams and usually require intense heat treatments. Ticks, they require a highly coordinated two-front attack, treating both the outdoor environment and the host pet with a vet's help. You absolutely have to know exactly who you're hunting.
Next up, we have lineup 3, the unseen invaders.
These are the deeply insidious pests that hide completely out of sight in our home pantries and massive commercial warehouses. And the stakes here are high. In the food industry, finding just one insect in a batch of flour can mean an entire cargo shipment gets rejected. We actually categorize these suspects by exactly how they attack. Primary pests, like weevils, are strong enough to bore right into whole, intact grains. Secondary pests, like flour beetles, are essentially scavengers that can only eat grains that are already damaged or milled into flour. And then we have things like the Indian meal moth, which are notorious for destroying domestic pantries. Nailing down the exact category dictates the professional response, like does this warehouse need a severe gas fumigation, a massive heat treatment, or maybe just some better moisture control?
All right, let's size things up and talk about the heavyweights, rodents. When we shift to these larger mammalian pests, the detective work changes from microscopic visual IDs to complex behavioral profiling. Let's break down exactly how technicians profile these guys in the field. Notice the black rat. It's got a tail that is actually longer than its body and a very pointed snout. But look closely at its habit. It's a climber. It absolutely loves roofs, attics, and even palm trees. Meanwhile, the brown rat is strictly a ground-level burrower. Think about what happens if you misidentify a black rat and lay all your bait traps on the ground. You are completely wasting your time. That rat is literally up in the rafters laughing at you while your very expensive treatment just sits untouched on the floor.
And here's exactly why that behavioral profiling has to be spot on from day one. Just look at this terrifying exponential math. Under the right conditions, a population of just 2 rats can explode to 1,000 in a single 12-month period. Their gestation periods are super short and their litters are large. A pest detective literally cannot afford a trial-and-error approach. By the time you realize your ground-level bait isn't working, that rat infestation has already multiplied totally out of control.
Now we have to talk about the so what of all this, the severe public health stakes attached to these suspects. This job is emphatically not just about getting rid of gross, creepy crawlies. It is literally about protecting human lives from disease. The brown rat can transmit leptospirosis and hantavirus. That tiger mosquito we talked about, a major vector for dengue and Zika. Cockroaches physically track salmonella and E. coli everywhere they walk. Even pigeons, which are controlled using physical barriers instead of chemicals, carry a major risk for cryptococcosis. Correctly identifying the pest means accurately identifying the specific disease risk they bring with them. Which brings us to our final section, the technician as an applied zoologist.
It is definitely time to elevate how we view the modern pest control worker. They aren't just chemical sprayers. They are highly trained applied zoologists operating in the field. And that brings us to the core thesis of this whole explainer. The technician who doesn't identify correctly cannot choose the right product. Taxonomy isn't theory, it's money and efficacy. Without pinpoint identification, the entire chain of action completely fails. The right product, the right placement, the right timing, all of it rests entirely on the foundational science of accurately identifying the specific organism sitting right in front of you. Precision in applied biology is the absolute baseline for success.
So, as we wrap up this explainer today, I want to leave you with one final, slightly provocative thought. Just look around your room right now. Check the dark corners. Take a glance at the baseboards. Maybe look at that potted plant sitting on your desk. Are you absolutely sure you know who you're sharing this space with? Because as we've clearly seen today, in the high-stakes world of the pest detective, what you don't know, and more importantly, what you misidentify, can truly become your worst nightmare. Stay curious, stay vigilant, and I will catch you in the next explainer.